Okay, we have a series, and we're going to find out if this converges or diverges. How are we going to figure that out? Well, we can first try to simplify this. First of all, like that numerator right there looks a little messy. So let's figure out what sine actually represents. So we have a circle, right? That's a really bad excuse for a circle. So we have a circle, and sine is the y value. Sine is a y value. So sine would be right there, sine would be right there, and sine would be right there, and so on, right? All around the unit circle, all around it. But the thing is, we have pi halves in here. We're multiplying pi halves. So pi halves is this one. Pi halves and 3 pi halves. And so then that would be 5 pi halves, and then this would be 7 pi halves, and then this would be 9 pi halves, and so on. So clearly, these right here are the ones we care about. So what are those values for sine? Well, the values are the y values. It's a unit circle with radius 1, so this is 1, and this is negative 1. So these are the terms that we care about, 1 and negative 1. And those are the terms that it's going to be for all things we plug in here, because if we plug in 1, that would be like plugging in 2 halves. You add 1 half, that would give you 3 halves. Multiply by pi, that's 3 pi halves. That's this value, negative 1. You plug in 2, you're going to get 5 pi halves. So 5 pi halves is if you move 2. So you would end up there, and you would get the value of 1, and so on and so forth. You would always get values alternating between negative 1 and 1. And we know how to rewrite that in a simpler form, which is just negative 1 to the n. So this would be negative 1 to the n, because that would cause this to alternate between negative and positive when you start plugging in numbers there. Whenever you have an odd number, this is negative. Whenever you have a positive number, it's even, in the exact same way that was going to happen for that one. So this is exactly equivalent to this with a series. So we have our series rewritten in a more simple form. Now we can do the alternating series test. Now that we recognize, hey, this is an alternating series, we could use the alternating series test to find if this converges or diverges. So how do we find if it converges or what does the alternating series tell us? What does the alternating series tell us? So the alternating series test has 2 conditions. So you go through 2 different steps. The first step is you want to make sure that b sub n plus 1 is less than or equal to b sub n. So that means that b sub n is monotonically decreasing. What is b sub n? It's just the region of this entire thing which doesn't have the alternating part. So it's everything minus the alternating part. You just forget about the alternating part, and whatever else you have, that's b sub n. So that's the first condition, that b sub n plus 1, so if you were to plug in n plus 1, it has to be less than or equal to b sub n. The second condition that has to be met is that when you take the limit as n approaches infinity of b sub n, this equals 0. If you meet both of these conditions, then it converges. That's what the alternating series test is, that if you meet these 2 conditions, you know it converges. If you don't meet both conditions, so if one fails or if both fail, then it might either converge or diverge. You would have to do another test. So that's how that works. So we're going to do this. The first thing we check is that it's decreasing, that it's monotonically decreasing. That's what this really represents. So in our case, is B sub n decreasing? So B sub n is 1 over 1 plus the square root of n, because we ignore the part which is alternating. Is this decreasing? Yes, it's always decreasing, because if we start plugging in numbers, the denominator is going to get larger and larger and larger. So obviously this is decreasing. It passes the first part of the test. The second part is that we take the limit as n approaches infinity of b sub n. So let's plug in infinity into this thing. What happens if we plug in infinity? We get infinity in the denominator. Infinity in a denominator, because the square root of infinity is just infinity, we add 1 to infinity, that's just infinity. 1 divided by infinity is 0. So this does equal 0. So it does pass both conditions of the alternating series test, and therefore it converges. If it hadn't passed, then we wouldn't know if it converges or diverges. We would have to do some other test. But since it passed both conditions, then we know it converges.